All right, this is a presentation about 9.2 reference and special angles. I'm going to get a laser pointer here to help me out. Okay, first thing I want to do is define a reference angle. All right, the reference angle is the measure of an angle from the x-axis, okay, and it's always going to be less than 90 degrees. Now, some examples. Let's look at the sine of 40 degrees. That's taken from the positive x-axis as usual, so there's the ray. And this reference angle is already 40 degrees, okay, because it makes a 40-degree angle with the x-axis. Okay. As a second example, let's look at the sine of 140. Taken from the positive x-axis, that's going to be this in green. But the reference angle is the angle from the x-axis, which will be this angle. And since the negative x-axis is 180 degrees, 180 minus 140 is 40. So the reference angle is once again 40 degrees. All right, now let's look at the sine of 220. 220 will be in this direction, the red direction, taken from the positive x-axis, right? But the reference angle will be the angle with the x-axis, okay, right here. And this, once again, 220 minus 180, that's once again 40 degrees. As a final example, let's look at sine of 320. And sine of 320, well, the angle 320 is there. And the angle with the x-axis is right here. And 360 minus 320 is once again 40 degrees. So for each of these cases, the reference angle is 40 degrees. All right, well, let's look at some additional examples here. Find the reference angle here. Well, similar to what we did up above here, if this is 150 and this is 180, then the reference angle will be 30 degrees. All right. Okay, let's say we're given this instead, negative 100 degrees. Well, let's see, where is that? Negative, I'm going clockwise from the x-axis, positive x-axis, and that's going to end up being right here. And then the reference angle will be the angle that this ray makes with the x-axis. All right, what will that be? Well, if that's negative 100, and if I go all the way to the x-axis, that's going to be negative 180, then that reference angle is going to be 80 degrees. All right, always positive and always between 0 and 90. Okay, or yeah, 0 and 90. All right, now let's look at this example, 7 pi over 8. All right, that's positive, so we're going to go counterclockwise from the x-axis, and I know that it's between 4/8 and 8/8, so that's going to be between pi over 2 and pi, so it's going to be in the second quadrant, and that's going to be in that direction right there, where this is 7/8, okay? Well, if that's 8/8, that makes this reference angle pi over 8, okay? Once again, acute, between 0 and 90 degrees, or saying it a different way, 0 and pi halves, okay? So those are what we call reference angles. And we're going to use those as we go here. Now, let's look at some special angles. There are some special triangles that we need to consider. One of them would be a 30, 60, 90 right triangle, okay, such as this. Now, we know that if the hypotenuse is 2, okay, and you can get this by taking an equilateral triangle of side 2 and doing a little analysis with it, we can find out that the short side is half of the hypotenuse. And then by Pythagoras, the short leg will be 1 and the long leg will be square root of 3. All right, so short leg 1, long leg square root of 3, hypotenuse 2. All right, for a 30, 60, 90. Now, let's apply this to a unit circle with a 30-degree angle in here. And remember, the unit circle has a radius of 1, and that would make the hypotenuse of this 1. Okay, well, looking up at our 30, 60, 90, the short leg is half the hypotenuse. And so here, the short leg will be 1/2. All right. And then by Pythagoras, you could determine that the long leg is square root of 3 over 2, which you can also get from here. If you take the long leg will be square root of 3 times the short leg. Square root of 3 times 1/2 will be square root of 3 over 2. Okay. Now, if we apply the that makes the ordered pair of the point on the unit circle root 3 over 2 and 1/2. Okay. Applying this same thing to a 30, 60, 90, where this angle is now 60, hypotenuse of 1 makes the short leg 1/2 and the long leg √3/2 once again. And so the point on the circle is 1/2 √3/2 as an ordered pair. Okay, now remember that the cosines of an angle are the x-coordinate of the point on the unit circle, and the sine is the y-coordinate. That makes the cosine of 30 degrees √3/2, and the sine 1/2. All right. Over here, in this particular case, the cosine of 60 is 1/2, the x-coordinate, and the sine of 60 is √3/2, the y-coordinate. Okay. All right. So 30 degrees and 60 degrees are special angles. There's another one. We can apply this to analyzing a 45, 45, 90 right triangle. Okay. Now in this case, if the one leg has length 1 and the other leg also has length 1 because it's isosceles, right? Then by Pythagoras, we can find the hypotenuse to be the square root of 2. All right. Now, applying that same thing to a unit circle, we find that if the hypotenuse is 1, each leg has a length of 1 over square root of 2. All right. Do a little Pythagorean theorem on this, and a squared plus b squared is equal to c squared. And you can see that that is true. All right. Now, we don't like to leave it as 1 over √2 because we have a radical in the denominator. So we're going to multiply this by a special form of 1, square root of 2 over square root of 2. And that becomes square root of 2 over 2. All right. And so we can write that as square root of 2 over 2. And that's how I'm going to write the coordinates of this point. Root 2 over 2, root 2 over 2. And that means that the cosine of 45 degrees is the x coordinate, square root of 2 over 2. And that's also the sine of 45, square root of 2 over 2. All right. So these are special values that we can have for the sines and cosines of 30 degrees, 45 degrees, and 60 degrees. All right, now let's apply this to find the exact value of the cosine of 120. Now, where's 120 degrees? It's right here. Okay. And note, and this point on the unit circle right here, if we draw in our triangle with our reference angle of 60 degrees, and you apply what we saw in the previous slides, a couple slides ago, we can see that the ordered pair for this point is negative 1/2 because it's a negative x-coordinate and a positive √3/2. Okay? And since the cosine is the x-coordinate, that makes the cosine of 120 negative 1/2. All we need to do is to read it from the ordered pair of the point on the unit circle. Okay? All right, sine of 210. Where is that? Well, 210, if this is 180, then it's 30 degrees past it, and that makes it right here. Okay? Our reference angle, if we draw in our triangle, then our reference angle will be 30 degrees. And if you apply what we found out, what we learned a couple slides ago, to this point right here, knowing that in quadrant 3, both coordinates are going to be, the x and y coordinates are both negative, then we get this for the coordinates of that point. The sine is the y coordinate. Okay, so that makes the sine negative 1/2. Okay? All we need to do is to apply that to the unit circle with these special angles. All right. Okay, one more. Tangent of 315 degrees. 315 is right here. Okay, 90, 180, 270, and then 315. Drawing in our triangle, 315 and 360 differ by 45 degrees. So 45 degrees is our reference angle. And if you apply the 45, 45, 90 analysis to this, all right, this coordinate will have a positive x coordinate and a negative y coordinate, and they will both be √2 over 2 in size. Okay, so we can get that coordinate. Now, what about the tangent? Well, the tangent of 315, tangent by definition is sine over cosine. And the sine of 315 degrees is the y-coordinate, and the cosine is the x-coordinate. So we get this. And then notice that everything cancels out. Okay, so except the negative sign, of course. And then, so that means the answer is -1. The tangent of 315 is -1. Okay, keep going. Now we have it expressed in radians, but nothing really changes. We just have to locate 5 pi over 4. Where is 5 pi over 4? Well, there's pi over 2, there's pi, and that makes 5 pi over, and that's 3 pi over 2, or 6 pi over 4, and so that makes 5 pi over 4 here. Drawing in our triangle, if we have 4 pi over 4, essentially, right here, and 5 pi over 4, that differs by pi over 4, and that's going to be our reference angle. Okay. Notice that that corresponds to 45 degrees. So we're on a little more familiar ground with degrees, perhaps, but pi over 4 is the same as 45 degrees. So we can apply the same type of analysis. And in the third quadrant, both coordinates are negative. So we have -√2 over 2, -√2 over 2. And then the sine is going to be the y-coordinate, -2 over 2. And that's our answer. The cotangent of pi over 4. Pi over 4 is right here. Take it from the positive x-axis. That's it. That's our reference angle. Okay. And these coordinates are both going to be positive. So we get that. Okay. And then cotangent. Well, cotangent, remember, is related to the tangent, and the tangent is sine over cosine. And so the cotangent is the reciprocal of the tangent, so that makes the cotangent the cosine over the sine. And now we can apply this, so the cotangent of pi over 4 is the cosine of theta, √2 over 2, over the sine of theta, or pi over 4, sorry. The cosine of pi over 4, which is √2 over 2, over the sine of pi over 4, which is √2 over 2, and that equals 1, and that's our answer. Okay, one more of these. Cosine of -2 pi over 3. Now we're going negative, okay? All right, now negative pi is going clockwise all the way to this axis. If I break that into thirds, okay, there's a third, there's a third, and there's the other third. Okay, so -2 of those is going to get us to right here. Okay, there's our triangle, and the difference between negative pi and -2/3 pi is the pi over 3. Keep it positive. Reference angles are always positive. Well, applying this, okay, pi over 3 is the same as 60 degrees. All right, and so we can apply the same thing we did for 60 degrees to here to get our coordinates, which are both negative, as -1/2 and -√3 over 2. All right. Once we have those coordinates, easily done, because the cosine is just the x-coordinate, which is -1/2. All right. All right. So it is in our interest to know all the x and y coordinates for everything on the unit circle, and that's what we're going to work on next. Write the ordered pair for each point, and we're going to end up making a reference sheet, and this is going to, so we can refer to it until we have these kind of ingrained. We're going to just list them, and then we're going to use this sheet as a reference, okay? That was for our 30-degree reference angle, okay? Remember that? So write this down as √3 over 2 and 1/2 as our x and y coordinates. And you should write this down as well, because this is going to get busy, all right? And we're just going to go all the way around the circle here, okay? So that coordinate, that point has coordinates √3 over 2 and 1/2, and this is for a 30-degree angle, which is also expressed as pi over 6. Now let's go here. The coordinates of this point are √2 over 2 and √2 over 2, and this is for a reference angle of 45 degrees, or pi over 4, which I'm going to write out here. Okay, let's keep going. Here, this is the coordinates. Notice all we do is reverse the 1/2 and the √3/2. Okay, that's kind of convenient. And then this is for a reference angle of 60 degrees or pi/3, which I'm going to write there. All right, let's keep on going. Here, this is for a point right there, which has coordinates 0, 1, and 1. And this is for a reference angle of 90 degrees or pi/2, which I'm going to write up here. All right, we're going to keep on going. We're going to go all the way around the circle, okay? For this one, okay? This, pause, what are the coordinates of this point? You notice we can get them all from the first quadrant points. Just apply the proper positive and negative signs. All right, so what is the coordinate of this point? Pause as needed. All right, try to fill this in yourself. All right. That one's going to be -1/2, +3/2. Negative x coordinates, positive y coordinates. This is for a reference angle of 120 degrees or 2 pi/3 in radians. Next point, negative √2. I'm not going to do this anymore. Okay, negative √2/2, positive √2/2. And this is for a reference angle of 135 degrees or 3 pi/4. Okay, what are the coordinates of this point? Negative √3/2, positive 1/2. This is for a reference angle of 150 degrees or 5 pi/6. Next point, that's a point on the x-axis that has coordinates -1 and 0. And the angle, I shouldn't say reference angle because they're bigger than 90 degrees. This is for an angle of 180 degrees or pi. Let's keep going. What are the coordinates of this point? Now we're in quadrant 3, so both x and y coordinates are going to be negative. All right. What are the coordinates of this point? Well, they're going to be negative √3/2 and -1/2. Can you kind of see the pattern going on here? This is for an angle of 30 degrees past 180, or 210, or pi/6 past pi, which is 7 pi/6. All right, right here, 45 degrees past 180. The coordinates are negative √2/2 and √2/2. I'm sorry, negative √2/2 and negative √2/2. And that is for an angle of 225 degrees and 5 pi/4. Keep on going here. All right. -1/2, negative √3/2 for an angle of 240 degrees and 4 pi/3. All right, what about right here? Ordered pair, 0, -1, angle, 270 degrees, or 3 pi/2 radians. All right, one more quadrant to go. We're in quadrant 4, so the x coordinates are positive, the y coordinates are negative. What about right here? This is going to be 1/2 and -√3/2 for a reference angle of, or not a reference angle, sorry, 30 degrees past 270 is 300 degrees, and 5 pi/3 in radians. Next one, √2/2 and negative √2/2. 45 degrees past 270 is 315 degrees, and 7/4 pi. Okay, right here, going to have coordinates √3/2 and -1/2. And that's for an angle of 330 degrees, or 11/6 pi, 11 pi/6. And finally, along the positive x-axis, it's going to have a coordinate of 1, 0, and that's for an angle of 0 degrees or 0 or 2 pi radians. All right, so we're going to use this as a reference sheet. Keep this handy until they become more familiar, and eventually if you work with these enough, you'll just kind of know them. But until then, keep this as a reference sheet to use. And let's use it to do this. We want to fill in this table. I just kept some of them. I didn't keep all of them because I need some workspace. Okay, so 30 degrees, where is that? That's right here. Okay, now What's the equivalent in radians? Well, I can just read that. It's right there. It's pi over 6. All right. What's the sine? Well, the sine is just the y-coordinate. What's the cosine? Well, cosine is just the x-coordinate. Okay. What about the tangent? Now, the tangent is defined to be the sine over the cosine. Okay. Now, the sine is 1/2, and the cosine is √3 over 2. Okay, now, the 2's in the denominators cancel out, and I end up getting 1 over √3. But once again, we don't like to leave radicals in the denominator, so we're going to multiply it by √3 over √3. And then that becomes √3 over 3, because √3 times √3 is 3. So tangent of theta is √3 over 3, which we don't need to memorize. We can just analyze it in this way. Okay. Okay. Next, the cosecant of 30. Now, the cosecant, by definition, is 1 over the sine. And the sine of 30 was 1/2. Okay, well, then 1 over 1/2. What's 1 over 1/2? Well, that's 2. So that makes cosecant 2. All right, what's next? The secant. All right, the secant is 1 over the cosine. All right, the cosine is √3 over 2. So I get 1 over the √3 over 2, which becomes 2 over √3. Okay, the denominator of the denominator comes back on top. All right. Once again, we don't like to leave it in that form, so we're going to multiply it by √3 over 3. And the √3's in the denominator combine to be 3. And so it becomes 2 √3 over 3. Okay, what about the cotangent? The cotangent is 1 over the tangent. But we know what the tangent is. The tangent is √3 over 3. So the reciprocal of the tangent is the reciprocal of √3 over 3, which is 3 over √3. And that becomes, after multiplying this, the √3 and the √3 in the denominator multiply to 3, which cancels out with that one, and we're just left with √3. Okay. All right, now, the negative degree. Well, let's see here. I know the degree is 30, and then we can go back to this business. So I'm looking for this all the way around to get the negative degree. Well, we can say if 30 degrees is theta 1, we're looking for theta 2. And we already know how to do that because we did that earlier, right? We use this relationship, which I subtract 30, and I get the absolute value is 330 degrees. And we just tack on the negative sign because we know it's negative, and that makes it negative 330 degrees. Okay, one more, finding the negative radian degree, more or less the same business, except this time we're going to use pi over 6. Okay, 2 pi over 6 becomes 12 pi over 6, subtracting to get 11 pi over 6, and then tack on negative sign because we want it negative, and that makes 11 pi over 6. Okay. Pause this video and see if you can fill in this table as practice. All right, answers. Pi over 2 radians corresponds to 90 degrees. Sine is 1. Cosine is 0. Okay. Tangent. Tangent is defined to be the sine over the cosine. The sine is 1, the cosine is 0. Anything over 0 is undefined. So the tangent there is undefined. The cosecant is 1 over the sine. The sine is 1. So 1 over 1 is just 1. Okay. Okay. Next, the secant. Secant is defined as the 1 over the cosine. Cosine was 0. And that makes the secant undefined. Okay. Cotangent. Cotangent is the reciprocal of the tangent. Okay, now this gets a little weird because we have to actually go back to define the cotangent as the cosine over the sine. If the tangent is the sine over the cosine, then the cotangent is the cosine over the sine. Okay. Now, if you might have first wanted to do that original analysis. Well, I want to take the reciprocal of the tangent. The reciprocal or the tangent is undefined. How do you take the reciprocal of undefined? So you can't really go there. You have to do it this way instead. All right, cosine over sine, and the cosine is 0 and the sine is 1, and that makes the cotangent 0. All right. And then by applying the other analysis where we're kind of going in the negative, that becomes negative 270. All right, negative 270, and then negative 3 pi over 2 for being negative radians. All right. All right, just a few more things to do. This is just for a reference, okay? Just for a visual. Here's the thing we need to do. If theta is between 0 and 360 degrees, find theta when the sine of theta is a half. All right, well, let's look around here. The sine is the y-coordinate. Which points has 1/2 as a y-coordinate? Here's one. All right, and there's another one. Can you find it? Yeah, it's there. And these correspond to angles of 30 degrees and 150 degrees. And those are our answers. What if the cosine is 1/2? Which points correspond to having a cosine or an x-coordinate of positive 1/2? Let's see, where would those be? Here's one. And there's one also. And those correspond to which angles? 60 and 300. Okay. All right. What about this one? The tangent of theta is -1. Well, these are just x and y coordinates. These are just listed in this reference sheet, are cosines and sines. So we need to analyze this a little bit. So now the tangent is equal to the sine over the cosine. All right. Now we want a tangent of -1. So the sine, the ratio of the sine to the cosine has to be -1. And if it's going to be -1, that means they have to have the same size. It has to be 1/2 over 1/2 or √3 over 2 over √3 over 2, such. But one of them has to be positive and one of them has to be negative. Okay, so I want magnitudes to have the same size, but one's positive and one's negative. Can you find one of those points? There's one. There's another one too. Can you find it? Right there. Yeah. And that corresponds to angles 135 degrees and 315 degrees. Last one. The cotangent is undefined. Okay. Now the cotangent is if the tangent is a sine over the cosine, the cotangent is its reciprocal, cosine over sine. And if it's going to be undefined, that means the denominator is going to be 0. So really, what I'm looking for are points that have 0 as a sine. Okay. Or 0 as a y-coordinate. There's one. And there's one. So these angles correspond to, this corresponds to 0 degrees and 180 degrees. Okay. So that's 9.2 stuff. And really, if you can, I don't know, I don't want to say memorize, but I guess I should. Memorize these if you can, just in the first quadrant, 30 degrees, 45 degrees, and 60 degrees. If you memorize these, and I suppose 0 degrees and 90 degrees, you should memorize those also, then you can use those to get all of the others, just remembering the signs of the x and y coordinates in each quadrant. All right, so memorize these just in the first quadrant from 0 to 90 inclusive, and you can get all the rest. And once you have that, you can do the problems, they're fairly quick, actually. So give the 9.2 practice problems a try now.